Hi viewers, I am Savitha Mary, Assistant Professor of Mathematics. In this subject, I am going to explain about the problem, assignment problem. So the assignment problem is nothing but it is assigning n job to n person. Each job to assign only one person. Each person can be allocate only one job. Suppose all the n persons are capable of doing any one of the n job, but the time taken by them to perform the job varies from job to job. So, our interest is to decide which job has to be assigned to which person so that the total time taken to perform all the jobs has to be minimized. So that the Hungarian method is very useful to find the total minimized time to assigning the job to a person. Here the method, Hungarian method, the procedure of the method is first from the given table we have to check whether the number of rows and columns are equal. If it is so, the assignment problem is balanced. Otherwise, it is an unbalanced problem. For the step 1, choose the least element in each row and subtract that particular element from all the elements of that particular row. For step 2, choose the least element in each column and subtract it from all the elements from that particular column. Check whether there is at least one zero in each row and each column and make an assignment as by the following procedure. First, examine the rows successfully with exactly one zero is found. If it is found as 0, mark the 0 by a rectangular box. That means an assignment is made there. And cross out the other 0 which lies in that particular column. Continue this process until all the rows has been examined. Then second process, examine the column successively until all the columns with exactly one zero is found. And mark the 0 by rectangular box, which means an assignment is made there, and cross out all the other zeros which lies in that particular row. So continue this process until all the columns and rows are examined. If each row and each column contains exactly one assignment, then the solution is optimal solution. So which means we assigned each person with a job to minimize the time schedule. This is the process of Hungarian method. Here we see an example problem and there is a table given by a task. 4 tasks are given for 4 persons, which means there are 4 rows and 4 columns. So the problem is a balanced problem. So the given problem is balanced problem. So we can use Hungarian method directly to allocate the job to each person. First, let us see the row reduction table. First check in the first row, there is the minimum element 8. In the first row, the first cell contains the minimum element 8 and reduce all the elements in the first row by the number 8 so that we can get a new row with the numbers which is reduced by the number 8 is 0, 18, 9, 3. Then from the second row, the minimum element is 4. They reduce the number in all the element of the second row so that we got the solution 9, 24, 0, 22 is the new elements in the second row. And then see the third row, there is the minimum element which is 15 and reduce the number 15 in each element in the third row. We got the numbers in the third row, the new elements are 23, 4, 3, 0. Likewise, in the fourth row, the minimum element is 10 and reduce the number 10 in each element of the row, fourth row. We got the new numbers 9, 16, 14, 0. So this is the reduced matrix. This is called row reduction matrix. Next, examine the column wise and see though, in the first column, we got the number 0. So the number 0 is the minimum number. So there is no change in the first column. So we got the same numbers in the first column 0, 9, 23 and 9. And now examine the second column, and that is the minimum number 4. So we can reduce all the elements in the second column by 4. So 14, 20, 0, 12 we got in the second column. These are the new numbers. Then in the third column 0 is the minimum number. So there is no change in the third column. In the fourth column also 0 is the minimum number. Therefore, there is no change in the fourth column also. So this is the matrix, which is a column reduction matrix. So after reduced the matrix, we got this solution. Then we can assign the jobs and see the first check the zeros which lies in the first row. Then there is a 0 lies in the first cell of the first row, and there is a 0 lies in this third cell in the second row, and 0 lies in this second cell in the third row, and then in the fourth row, fourth cell having 0 element. So I am going to allocate that 0 element, the first row, first cell, I am allocate that element, and there is no other 0 in the first column. Likewise, in the second row, in the third place there is 0. So I am going to allocate the 0 and check whether there is another zeros in the column, the third column. There is no other zeros in the third column. So move on to the another row. Third row, there is one 0 and 0 lies in the second cell. In the second column, there is no other zeros. So I can allocate that element 0. Then see there in the fourth row, the fourth element is 0. So allocate that 0 and check whether there are another zeros in the fourth column. I got this 0 in the fourth column, third row, fourth column, third row, fourth place, one more 0 is there. So I can strike out that 0. And now check whether all the rows and columns having the assignment. In the first row, there is one assignment. Second row, there is one assignment. Third row, assignment is there. Fourth row, assignment is there. Likewise, in the first column, one assignment is there. Second column, there is one assignment. Third column, assignment is there. And fourth column, assignment is there. So we got the optimal solution. And you can compile the solution like this. So the person A is allotted with the job, task 1, and he has 8 hours to complete the job, and person B allotted with the task 3 and he has working time 4 hours, and person C allocated with job 2 and he taking time 19 hours, and the person 4 allocated with the fourth task and he will taking time of 10 hours to complete the job. So all the job will be completed in 41 hours. So this is the optimal solution of the assignment problem. Thank you for watching the video.